the project we are doing right now is called Mind the Gap. Why are there many gaps between the state of the environment on the one hand and the environmental objectives on on the other hand? And I will talk a bit about different aspects of this this project, and also end with at least my understanding that a much better world from a sustainability point of view is possible. If we take the environmental dimension in sustainable development, the Swedish Parliament has since the 1990s stated 16 different environmental quality objectives, including reduced climate impact, zero eutrophication, rich diversity of plant and animal life, non-toxic environment, etc. And it's only one of these objectives that's considered to be reachable, and that's a protective ozone layer, the ozone layer that's 20 kilometers up in the stratosphere. Because that's an area where policymakers have listened to scientists and taken action. So by the end of this century, we might have a ozone layer that's functioning fully again. So why are there gaps between these objectives and the state of the environment? Why is it so difficult? Well, these are issues that have been raised for many years by many scientists in different disciplines. And of course, lack of scientific knowledge is a very basic explanation why there are environmental problems. If we don't know what's happening, eventually we will notice that, and then we run into the wall of problems. There are also uncertainties. We have institutional inertia and technological lock-in. If you pave a road, if you dig down pipes, etc., those infra systems are difficult to change, even though we know that they are causing problems. Goals and targets can be weakly operationalized. We have social dilemmas and controversies of different kinds. Weak or ineffective regulation, which is something that lawyers work in, environmental law researchers and environmental economists focus on. A lack of internalization of external costs. And the idea is then to put a price on the environment, so you visualize that in the economy and people take action on thereafter. And lobbyism, etc., etc. So what we ask ourselves is that, well, when we know a lot about the problems, we know a lot about the reasons for the problems, and we also know how to deal with it. We have insufficient cost internalization. We know how to impose environmental taxes. We know that that could be effective, but we're not doing it. Why not? Well, we don't know that, and that's the reason why we have a research project where we try to dig a bit deeper and ask ourselves why, considering the amount of knowledge that we're having about problems and solutions and the reasons why we're not imposing the solutions, why are we still seeing these gaps? Are there things underneath? Are there things within the systems as such in the relationship between science on the one hand and policy on the other? I'm not saying now that policy making is everything. There are a lot of voluntary initiatives, of course, among corporations, individuals change behavior on a voluntary basis. But as long as the incentive structure is working against that, when what is bad for the environment is cheaper than what's good for the environment, of course it's difficult for companies and individuals to change behavior, to change systems. If we subsidize fossil fuels, of course people will use fossil fuels, and it's very strange for people if we subsidize fossil fuels, and when people then use fossil fuels, we try to tax them for doing exactly what we have been subsidizing. A very basic ideal picture is that science speaks truth to power in a way, and that policymakers act on basis of science. A lot of scientists still think this is how it functions. Well, we've told them the truth. Why are they not acting? Well, a more realistic picture could look like this. When science and policy first are two spheres that are overlapping, where we have scientists as agents, and scientists are also acting in the policy sphere, coming with recommendations, then normative statements of different kinds. We have this false understanding that science is value-free and that scientists are not operating. But numerous studies show that scientists, of course, also take a stance in policy making. I don't see that as a problem as long as you're transparent on your norms. We have politicians interfering in science, guiding science, of course, with budgets, but also interpreting science in different ways. We have the public, we have civil society, media, business. So a very blurred situation where that scientists speak truth to policymakers and that act on that basis is seldom functioning as straightforward as one could think. And there are, of course, a lot of distributive issues in the policy sphere as well. Who is bearing risks, the cost of risk, and who is benefiting from risk taking, etc. It's not necessarily the same actors all the time. So I will go in a bit into areas of this science policy relationship that we've been studying. First relates to science as such, and the occurrence of science denial, climate denial, as it's sometimes called, not climate skepticism, because of course it's in the nature of scientists to be skeptical. Donald Trump said that global warming is a kind of Chinese invention and things like that. And we made a study when in which we went through all the scientific studies that have been published from 1990 to 2015. We didn't look at the deniers' publications themselves, but a scientific inquiry of the phenomenon of denial, and looked at what is denial, how is denial understood, what are the reasons for denial, how can denial be coped with. And the focus here is on climate change. It's, say some 80% of the studies we reviewed relate to climate issues. And when we published this in Svenska Dagbladet, in an op-ed in a Swedish newspaper, we actually got a commentary from two researchers showing that denial is also in the environmental green country of Sweden a fact. And among other things, they said that the President Obama, who said that the science on climate is settled, was mistaken because science is never settled, and they cut out, I think, 5 words from a very long speech by Obama where he went through all these scientific insights and summarized that, and they said that, well, that's the unscientific president, indirectly saying that, well, Donald Trump is right. One of them is vice chairman in the Swedish Meteorological Association, which is quite astonishing to see how they completely deny scientific findings. Of course, science is never fully settled, but once in a while we need to say, well, this is what we know, and we need to act on that behalf. Of course, not neglecting criticism in relation to that, but denial is something very different. So even here in so-called Green Sweden, there is a debate about these issues. But the number of scientists, the share of scientists being deniers is really small. There are studies looking into this, so 97-98% of scientific community agrees with the International Panel on Climate Change, and some of those not agreeing are saying that, well, problems are worse even. What is being denied? Well, the trend of global warming, that this can be attributed to a large extent to mankind, and that impact is overall negative, is denied. But there's also consensus denial, saying that, well, scientists do not agree. Look, we had 2 scientists just on the previous slide saying that this is not the case. And media is then problematic. I will come back to that, saying, well, what do you think? You're a scientist. What do you think? You're a scientist. And they had 2 scientists with different views. And of course, the viewers think that scientific community is divided, 50-50 perhaps, as a media balancing principle. And then implicatory denial is also important. Well, okay, this is happening. It's due to mankind. Effects are negative, but I don't agree with the measures, so therefore I'm denying this. I don't want you to take measures in regulating traffic or pricing externalities. So very few scientists, some governments, that's now decreasing. Several political and religious organizations, on the right side in particular, conservative organizations in the US, some fossil fuel industries, some media channels are making this a big issue, and also within the public, predominantly in Anglo-American countries when it comes to climate issues. Of course, denial can be explained by help of theories in psychology and sociological factors in groups, but it relates also to values and worldviews. And there is a denial machine, kind of organized denial, financed by fossil fuel industry or think tanks and so on, that cause a lot of problems. Well, how can you counteract that? Not necessarily taking a debate with the deniers as such, because it's difficult when cherry picking and other things are coming up. Well, you know, the temperature in inner Siberia 1952 was like this. How do you explain that? It's an anomaly. So it's very difficult. So therefore, perhaps it's better to expose their tactics, their financial basis, and communicate benefits of climate change, and education, changing scientific practices, working more with consensus, and so on. The second study I want to highlight is a background report to the Swedish committee on the Parliamentary Committee on the New Climate Act. We wrote on climate policy under uncertainty and cost and benefits, decisions and evidence. And we looked at what are the costs and benefits of inactivity and activity, and the focus in policy making is that, well, this is very expensive. Minus one, of course, if you improve efficiency or save electricity, you can benefit from that, but up to 4% of GDP to take measures to mitigate climate change. But if we consider what's happening now with the temperature having increased more than 1 up to 1.5 degrees over time, these are the scenarios by the International Panel on Climate Change. This is the Paris Treaty range, 1.5 to 2 degrees. We see that the coral reefs in the world are probably going from a kind of yellow to red situation if we approach the 2-degree level. So coral reefs might disappear completely. And we have vicious circles, permafrost melting, methane going up, warming, etc., and more meltdown of permafrost and more methane. So at different levels here of warming, 2, 3, 4, 5 degrees. And it's extremely difficult to predict these global Earth system tipping points. Where are they? You can never capture that in cost-benefit analysis in climate economics. So that makes it very difficult. And also the fact that climate sensitivity, which is the temperature that will occur when we have a doubling of CO2 levels, is not a normal distribution here. You know, the normal curve would look like this. We have fat tails on the right side. So there is a probability that's pretty high still for 4, 5, 6 degrees. And if we go above 2 degrees, we go outside of the temperature interval, the climate interval that mankind has developed all societies in. Since we started cultivating agriculture, since we organized cities and things like that. So it's really beyond what humanity has ever experienced. And the probability for this is not something that we can look away from. And that's making things even more difficult. So different studies come up with 5 to 20, 1 to 14, 20, 14% GDP losses. So the cost of inactivity, of business as usual, are of course much higher than the cost of taking measures. Jerome van den Berg showed that the social costs of carbon are above $125 per ton CO2. That's higher than the highest CO2 tax in the world for Swedish consumers. That's a careful bottom estimate. In addition to this, though, we have a lot of co-benefits resulting from policy making. We can improve efficiency and savings, increase supply of renewable energy, protect carbon sinks, and this leads to less noise, less air pollutants, and welfare gains. And there's a big scheme of these benefits that we can identify. That's seldom done in policy making. So if we look at that, the amount here is 1 to 14%. The 15 countries emitting most greenhouse gases have air pollution costs amounting to 4% of GDP. So if this costs 1 to 4% of GDP and the benefits are up to 4% of GDP for those emitting most, well, it's a free ride. And if we consider the cost that we miss. I mean, it's 2-0 to taking measures. Still, in policy making, the focus is all the time on this. How much does it cost? How much does it cost? How much does it cost? And that's a key question, but it's worthless for policymakers if you don't ask yourself, what does it cost not to take measures, and are there co-benefits? Then we have a very biased situation in policymaking, and it's the policymakers themselves that have invented this system of proof. You can see the same in, this is about biodiversity and wolf hunting. Scientists say that there's an abuse of science in setting policy. Manufacturing doubt about endocrine disrupting chemicals. Publications. We had a roundtable on that. Different agencies have different norms. Here, differing 50 times, depending on if they imply a precautionary measure, precautionary assessment or not. So these scientific findings are blurred, and in many cases, it's difficult then for policymakers to come to conclusions. So what can we do then? Well, processes for building scientific consensus are or could be important in several cases relating to sustainable development. We have the IPCC consensus mechanism on climate issues, but we might need it for biodiversity as well. There are panels, but not consensus-seeking panels to the same extent as for climate. We might need it for toxic substances, we might need it for marine issues as well. So establishing scientific consensus is giving science a stronger role in policy making. And it is important to clarify differences between science and policy and to be transparent on values when there are overlaps. I mean, my starting point is when I give recommendations that, well, the Parliament has decided on 16 environmental objectives. So how can I come to these recommendations? Well, they are meant to improve the achievement of these objectives. That's my value basis for giving a recommendation, for example. Of course, it can be more specific. Conventional criteria and processes for decision-making, such as cost-benefit analysis, are commonly insufficient in relation to complex environmental problems. Still, though, that is the general prerequisite for policymaking, according to the Minister of Finance. If you haven't done a kind of cost-benefit analysis, in spite of all the problems with these tools, you can't come to conclusion. You cannot come to decision. And that's blocking policy, that's deepening the gaps between the state of the environment and environmental objectives. So politicians have set decision-making thresholds for themselves which they cannot jump over, which is an explanation, as we see, for these gaps. Often the costs of action are significantly lower than the cost of inaction. That's valid not only for climate, it relates to chemicals, toxic substances, for instance. And even more often, substantial co-benefits are overlooked in decision-making. I was an expert in this governmental committee on the new Climate Act, and they asked, as I said, this question, how much does it cost? How much does it cost? And didn't ask, what does it cost not to do it? But the co-benefits were not considered, more than very superficially. And the proposal consisted of, first, the Climate Change Act and package, and then a package for decreasing air pollution, and they calculated the cost for achieving the climate targets, and then they recalculated the cost for achieving the air pollution targets, even though you reach both targets with the same measures. So the understanding was that this might be twice as expensive as it was. I'm summarizing a bit here, of course, but these co-benefits are really overlooked. There were figures in the text of this committee, but not more than that. How much does it cost? We can't do this because you haven't calculated the costs. And of course it's difficult. How can you calculate the costs for melting tundra the coming 200 years? What's the price of coral reefs being gone from Earth the coming 200 years? And so on. So finally, more stringent policies are needed, implementing precautionary and participatory strategies as well as supplementary measures. And just to give you some pictures here, decision makers understand this. If they consider likelihood and impact, environmental issues are on top in the global risk report in the World Economic Forum. European Resource Efficiency Platform showed that, well, if we take these measures, we can increase economic growth and increase employment. If we are more efficient on resource use, we can generate more jobs. Environment and economy go hand in hand. It's not a contradiction between these. there are now studies showing that we can go down to 1.5 degrees. And when Trump said, well, I don't care about climate change, the rest of the world didn't say, as 5 years ago, okay, we leave as well. They say, bye-bye. You will come back to the table eventually. We're going to continue because we see all the benefits coming from this. Swedish companies want to see tougher legislation. A majority are saying more stringent laws, more stringent economic tools. And the public is concerned. Environmental damage is on top on the concern list when scientists ask them about this. So we have politicians coming on board, scientists coming on board, companies coming on board, and the public is supporting this. The final point here is the most problematic environmental goal was the depletion of the ozone layer. The CFCs depleted it, it increased. Well, we had a Montreal Protocol. Scientists showed that that's not sufficient. We had a London Protocol, we had a Copenhagen Protocol, etc. And this has led to, in just a couple of decades, decreased emissions, and eventually the ozone layer will come back. That's the most serious environmental problem, much more serious than climate change. And thanks to global collaboration between scientists and politicians, that science has been fed into policy making, supported by business as well, we'll probably handle this problem. So we know how to do, and the Paris Treaty on climate change is showing, together with this global sustainable development goal, well, the world is really now finally coming on right track. Thank you very much.